morning everybody. My name is Biplab Bhattacharya. I am a professor in IIT Roorkee and I am going to run this course Introduction to Sequence Stratigraphy, and under this particular course in this first class I am going to give you a brief introduction about the course and also what is sequence stratigraphy. So, sequence stratigraphy is one of the emerging branch in earth science which has very wide application in various aspects, various sectors. The most common aspect where we apply the sequence stratigraphy is the oil industries, hydrocarbon exploration, but apart from that we also apply sequence stratigraphy concept in many other instances, starting from identification of different mineral exploration, identification of coal deposits, etc., etc. So, in this particular course we will be looking into the basic understandings of what is sequence stratigraphy, what actually we do in sequence stratigraphy, how it is different from the other branches of traditional or conventional stratigraphy, what are the advantages and disadvantages, what are the scopes and applications of sequence stratigraphy in the overall regime of earth science, in different fields of earth science, and how this concept of sequence stratigraphy evolved historically. So, many of these questions will be answered in successive classes. In this particular class or maybe in the next class, I will just try to give you an overview of what are the answers to these basic questions, but we will discuss all these topics, all these aspects in more detail. The detailed syllabus is already outlined and it is available to all of you. So, there you can see that we will be covering up each and every detail of sequence stratigraphy, and we will try to learn that how these different elements of sequence stratigraphy are identified, how they are defined and how they are applied in the practical world. So, in today's class we will try to understand what is actually meant by sequence stratigraphy. Sequence stratigraphy, this is a branch of geology, specifically there is a branch of stratigraphy, a newly emerged branch of stratigraphy, where we try to attempt understanding the historic geology through time by subdividing and linking the sedimentary deposits into unconformity bounded units on a variety of scales. So, basically in sequence stratigraphy what we try to do is we look into the rock successions, preferably the sedimentary rock successions, and there we try to find out if there is any break or any gap in the sedimentation. As we know, the basic definition of unconformity, there is any gap or break in the sedimentation which may be due to erosion or which may be just because of some bypass, some gap in the sedimentation process. So, that will be represented in terms of a particular surface which we call as unconformity. So, in sequence stratigraphy we try to identify unconformities present within the sedimentary succession, and the package of sediments which are present in between two successive unconformities are considered for sequence stratigraphy. There may be several unconformities present within one succession. We can deal with several packages present in between those unconformities, and we try to apply this concept of sequence stratigraphy for those packages. So, when we deal with those sedimentary packages covered or bounded by the unconformities, they appear in different orders, they appear in different architectural arrangements which we commonly call as the stratal stacking patterns. So, in sequence stratigraphy, first we try to identify the bounding surfaces, very commonly they are the unconformities, and those unconformity bounded packages commonly appear in terms of stratal stacking pattern. So, those stratal stacking pattern bear certain importance, certain significance in terms of the depositional conditions, in terms of the control factors which are acting in the depositional environment at that particular time. So, when we combine all this together, what we get is interpretation of the paleodepositional environment, and together when we look into the in larger scale, we try to interpret the overall paleogeographic condition in that particular basin. So, the sequence stratigraphy blended both autogenic and the allogenic processes or allogenic events which are occurring within a basin. Now, the question arises over here that what do we mean by these autogenic and allogenic processes or autogenic and allogenic events. So, any process or event which is occurring within the basin and which is part of the basin. So, commonly we call them as the formed within the system. This system has a different meaning. Here I am using the term system in a loose term, not in a technical term, because later on we will have a more technically defined term system. So, that we will discuss later on. So, within these autogenic factors, what we consider are the normal processes which are going on in a sedimentary basin. For example, a river is flowing, it is carrying sediments, they are getting deposited. So, within a river what we get is a channel. Same kind of channel may be present in a delta, same kind of channel may be present in a tidal flat, same kind of channel may be present in an estuary. So, those channels, they are carrying the sediments as per the energy condition available, as per the sediment supplied into them, and they are depositing in different parts and producing different types of phases. So, all these normal processes which are going on in a sedimentary basin or a depositional system is called as autogenic factor or autogenic controls, and these are controlled by normal basinal processes. On the other hand, the allogenic processes, they are something from outside, they are some outside factors which can affect the depositional process. For example, some climate change, maybe some global climatic change. So, that global climatic change will affect the local sea level conditions, and those changes in the sea level condition will affect the local depositional conditions. Again, another allogenic factor, say for example, any tectonic activity, say in a basin which is tectonically active. So, there we can have subsidence in the basinal part or maybe exhumation in the hinterland area, in the shores area. So, in response to that subsidence, there may be sudden increase in the sediment supply, sudden increase in the erosion in the continental side into the shores area, which may lead to abrupt change in the depositional product, which may also change depositional condition, depositional processes. So, all these factors which are not directly part of the basin itself, they are occurring in much larger scale across the globe or maybe covering part of the globe and can have significant effect on the basin scale processes. They are called as allogenic factors. And in any basin, when this kind of successions are developing, there we can have effect of both of these factors, autogenic factors and allogenic factors in building up the overall sedimentary succession. So, whenever we think of making a depositional model from any basin fill succession, we have to consider both of these autogenic and allogenic factors. What are these processes, how they are affecting, and what are the resultant products. So, these autogenic and allogenic factors actually control the evolution and development of the stratigraphic architecture in any sedimentary basin. So, on the contrary, when we try to interpret the sedimentary basin fill architecture or stratigraphic architecture, first we have to understand what are these autogenic and allogenic processes going on or went on at that particular basin at that particular time. So, the importance of the process sedimentology, which is one of the major pillar in sequence stratigraphy, it becomes very evident, very prominent when attempting to identify different elements within sequence stratigraphy. For example, when we are trying to identify the sequence, when we are trying to identify the boundaries within the sequence, or we are trying to identify smaller units like the system strats. You may be little bit confused that what are these terms, sequence, system strats, what are these terms? Do not worry, we will discuss about these terms in more detail in next classes. So, identification of the unconformities is a very important factor, and the type of unconformity, nature of the unconformity, its prominence will vary from environment to environment. In a non-marine environment, for example, in a fluvial environment, the unconformity may be very prominent, whereas if we move on to the marine environment, towards further deeper part, maybe in the shelf, maybe in the slope area, there the unconformity may not be that prominent, even it may be missing. So, all these factors actually control what will be the nature of the sediment packages that we are dealing with. So, in sequence stratigraphy, we have to understand what are the processes involved and what are the responses. So, basically we refer to the process response model in sequence stratigraphy, which actually gives us idea about the distribution of different depositional environments or different depositional systems and the distribution of the bounding surfaces, which are commonly the unconformity surfaces. The stratigraphic component of sequence stratigraphy, it consists of its applicability to correlations in a time framework, usually beyond the scale of individual depositional systems. So, we refer to some major events which are occurring within a time frame, and in between that time frame, due to that event, all the sedimentary environments occurring across the basin are getting affected. So, when they are getting affected by certain processes, their responses will be different depending on the hydrodynamic condition, the energy condition, the bathymetry, depth and sediment supply, nature of or type of sediments which are available into that particular system. So, based on that, we can get different architecture, we can get different responses, which gives us clue to identify different sequence elements or different components in sequence stratigraphy. So, sequence stratigraphy is a very useful alternative to other branches of stratigraphy, particularly if I compare with lithostratigraphy, which is a very common branch of stratigraphy. So, in lithostratigraphic approach, what we do? We solely emphasize on the compositional similarity of the lithology of the rock units. Basically, we try to identify similar rock types which are present, which are occurring, and we try to distinguish different lithostratigraphic units like formation, group, supergroup, etc. And that is solely based on the lithological similarity, lithological commonality, and we do not care about the other properties or other components like how they have formed, what is the origin, what is the processes involved in the formation of those rocks. But in sequence stratigraphy, we are more concerned about how they are formed, what are the processes involved, including these autogenic and allogenic processes, and in which time frame they are forming. In lithostratigraphy, we do not take care of the time. So, sequence stratigraphy has some advantages over the lithostratigraphy or other branches of stratigraphy. This we will again discuss in more detail in later classes, that how and where sequence stratigraphy differs from lithostratigraphy and what are the advantages of sequence stratigraphy over lithostratigraphy, that we will discuss later on. So, if I talk about the other conventional types of stratigraphy, for example, biostratigraphy, lithostratigraphy, chemostratigraphy, magnetostratigraphy, all of these stratigraphic branches, they have their own advantages, they have their own way of defining the stratigraphic successions, and they involve certain properties of the rock. For example, if I talk about the biostratigraphy, it deals with the biological parameters, biological properties of the rock, and based on that we try to define the stratigraphic units like biozone. If it is a magnetostratigraphy, we try to identify or we try to emphasize on the magnetic polarity developed within the rock, and based on variation in the magnetic polarity, we try to define different magnetostratigraphic units like polarity chronozone, etc. All these types of branches of stratigraphy, they are good in their own capacity, in their own realm, but they have certain limitations as well. For example, if I talk about the lithostratigraphy, there we do not consider any age. There we are only concerned about the rock property, that is all. In case of biostratigraphy, it is solely based on the fossil distribution, fossil assemblages present within the rock. If we go into the deeper time, for example, into the Proterozoics, where the fossil abundances are negligible, there the application of biostratigraphy is very much restricted. Also, even within the Phanerozoic, there may be certain horizons where we do not get any fossils, or very rarely we get fossils. So, there the application of biostratigraphy is very much restricted. Similarly, for magnetostratigraphy, the magnetic property, magnetic polarity that goes on destroyed with age, because the rocks they go on through different phases of deformations and metamorphisms, and that destroys the original or primary magnetic property preserved within the minerals within the rocks. So, as we go down the deeper time, there are very rare chances that we can apply magnetostratigraphy in those rocks. Magnetostratigraphy is very good for younger rocks, for the Cenozoic rocks, but if we go down to the Paleozoics, there it is very often it is very difficult to do some work with magnetostratigraphy. I am not saying impossible, but it is very much restricted. So, all these branches of stratigraphy, they are based on particular type of data set which have certain limitations. But in case of sequence stratigraphy, we do not require such kind of dependency on certain database. There we can accumulate different data, different inputs, and based on those inputs we can go for a genetic interpretation. And since we are going into genetic interpretation, so it can be done using various components, and as a result of that the sequence stratigraphy is much more advantageous over the other stratigraphic branches. So, definitely this gives us certain advantages over the other stratigraphic branches. So, basically what we can think of, there are two end member components. We do certain work under the branch sedimentology, where we try to understand the sedimentary rocks and we try to understand or interpret the sedimentary environments. Under this sedimentology part, we are mostly concerned about the process component, what we call as the process sedimentology, and based on this process factor, we try to interpret what has happened in that particular depositional environment. Here, when we are doing the sedimentology part, we are not concerned about the time aspect. We are only concerned about what are the processes involved and how these processes have resulted in certain products which are appearing now as a sedimentary rock or a succession of sedimentary rock. So, this is one component where we are getting the process response part. On the other hand, another end member is the stratigraphy part. So, in this stratigraphy part, we are not concerned about the process response, but what we are looking over there, we are looking at the overall succession, and those successions are arranged and interpreted in terms of time. So, we have a time connotation which actually controls the stratigraphic study. So, in stratigraphic study, what is more important is arrangement of the successions in terms of time connotation, and for that purpose what we apply is a very common process called as correlation. So, correlation is a very important process, very important tool in stratigraphy which helps us to understand laterally distributed units, arranging them in terms of increasing or decreasing age. So, in case of sequence stratigraphy, what we do is we try to bridge between them. Here we apply this process response model of the sedimentology and this time correlation of the stratigraphy together, and we try to develop a model which we call as a sequence stratigraphic model, where both of these aspects are merged together. So, we try to arrange the sedimentary successions in terms of correlations, in terms of time frame, and we also try to understand how they have formed, what are the processes and the responses with respect to different autogenic and allogenic factors within that particular time frame. So, sequence stratigraphy is a kind of bridge between stratigraphy and sedimentology, two end member components, and sequence stratigraphy is bridging these two end member components together, and we are coming up with much better interpretations, much better results. So, sequence stratigraphy is a relatively newer branch which has developed in last 30 years. Actually, it started developing, this concept of sequence started coming almost 70-75 years back from now, but actual development in this particular subject area that has occurred in last 30 years. So, initially when 70 years back, 75 years back, when this subject or this concept first started growing, it was based on one particular aspect, one particular dimension. But in last 30 years, the subject has opened up, it has evolved, and during this evolution, it has opened up to incorporate data, incorporate interpretation from many other branches of earth science, and which has actually increased the scope of interpretation, the scope of application of sequence stratigraphy in different aspects. So, it starts with regional phases mapping, which is basically started from sedimentological work, but it also adds on input from geophysics, which is a major pillar, which is a major fundamental unit in constructing the sequence stratigraphic architecture, particularly when we are trying to look at a larger scale, a basin scale picture, because geophysics can give us a basin scale picture which may not be possible from just sedimentological study from certain outcrop sections. When we look into the major components within sequence stratigraphy, we can think of three major pillars. Number one, the integrated disciplines or the subject areas, which are directly or indirectly involved in sequence stratigraphy. So, what are those subject areas? So, definitely it starts with sedimentology. So, apart from sedimentology, what are the other areas that can help in supplying the input, supplying data, supplying information? Definitely the second one will be geophysics. So, sedimentology and geophysics, these two are the major input for sequence stratigraphy. And when I am meaning sedimentology, it includes the stratigraphy part also. Apart from these three areas, we can get input from geochemistry, we can get input from geomorphology, we can get input from isotope geochemistry, and also we can get input from, or we can include data from basin analysis. So, these are some of the subject areas, not all. These are some of the subject areas which can be directly or indirectly get involved in sequence stratigraphy in terms of supplying or interpretation of data. Definitely this is not an exclusive list. There are many other subject areas which can have direct or indirect link. For example, structural geology, for example, tectonics, for example, climatology, for example, oceanography. So, all these are directly or indirectly related to sequence stratigraphy, and in different cases from different basinal successions, from different areas where you are working, these subject areas can have a very prominent role in terms of input of data, interpretation of data. Now, coming to the second component, which is the second pillar in sequence stratigraphic study, is the data input. So, within this data input, I am trying to tell you that what are the sources of getting data for doing a sequence stratigraphic study. The best way of doing sequence stratigraphy is definitely some subsurface data. So, those subsurface data can come from geophysical analysis, which can start with seismic data, which can start with well log data, and which can start with core data. So, seismic data, seismic profiles of the entire basin, even across the basins, well log data from different parts of the basin, core samples from these wells. So, they give us idea about the subsurface rock types and their distribution pattern, and this is very much useful, particularly when we do not have the surface exposures, we do not have the outcrops available for study, or even maybe outcrops are available, but they are very scanty, they are not sufficient enough to carry out a detailed sedimentological or sequence stratigraphic analysis. In such cases, these are the major component which provides us the basic data. Apart from that, Definitely the outcrops, they are major source of data, major input, wherefrom we can straightway get idea about the individual sedimentary rock bodies, their properties. We can get idea about the boundary conditions, how one bed is transitioning into another one, what is the nature of the contact, and how they are regionally distributed. So, if you have a good outcrop, there is no substitute of that. It is the best source, best input for doing sequence stratigraphic study, for sedimentological study. But the problem is, in many areas we do not get good or continuous outcrops, and there we have to look for this subsurface data, which commonly comes from the geophysical components. And apart from the outcrops, very often we also look into the modern analogues. So, these modern analogues, which include say for example, some processes which are going on today. A bar is forming in the fluvial system, in the river system, and that bar is migrating. So, we can observe that. We can observe the processes, we can observe the products, and those modern analogues can be used, can be compared to interpret the ancient processes or ancient deposits. As we know that the law of uniformitarianism, a basic principle in stratigraphy that says present is the key to the past. So, we look at the present considering that the processes which are going on today used to continue in the same way in the past as well. So, present is the key to the past. So, using that we can also use modern analogues in certain cases as a data input for interpretation part. And then comes the third pillar in this particular study is the interpretation of the controls. So, what are the controls that can produce or that is producing a sedimentary succession where we are applying the sequence stratigraphic model or sequence stratigraphic study. So, there can be several controls. For example, sea level change can be one major control, it can be climate, it can be tectonics, it can be some autogenic or allogenic factors. So, these are the different factors which commonly controls the nature of sedimentation, the character of the resultant product, and what kind of sedimentary succession has developed, has formed, where we can apply this concept of sequence stratigraphy. And once we are applying this concept of sequence stratigraphy for the interpretation of the basin fill succession, that can have a direct application in the industries as well as in the academics. In academics, we can go for basin analysis, we can go for interpretation of the paleogeography of different successions. And in the industry, this study can lead us to exploration of resources. Very commonly that is done in the oil industries. So, the application of sequence stratigraphy apart from into the predictive exploration of petroleum or hydrocarbons, it can have much wider applications. For example, for the exploration of coal, for the exploration of placer deposits, which also includes certain critical minerals, and mineral explorations. In recent years, we have seen that sequence stratigraphic study has been amalgamated with the isotopic study, and there the input from isotope geochemistry has improved our interpretations, our understanding level in terms of the development, growth or decaying of the ice sheets, change in climate conditions and associated sea level changes, and often help us to clarify the role of eustacy in the evolution of stratigraphic succession. So, this is the new term that I have just used, eustacy. So, that is basically the global sea level changes, global sea level rise or global sea level fall. So, that we will discuss again in detail in later classes. Now, very quickly, if I want to look into the historical development of sequence stratigraphy, how this subject has developed. So, this particular subject is a very new subject if I compare that with respect to other traditional branches of earth sciences, and basically it developed in last 70 years, and the major evolution, major changes came into practice in last 30 years. So, basically the concept of sequence stratigraphy, it stemmed from the original seismic stratigraphy concept, which was very much popular in the 1970s. Seismic stratigraphy has certain limitations, And to avoid those limitations, to overcome those limitations, some other aspect, some other approach was introduced in the form of sequence stratigraphy, where the work started with defining the term sequence. So, in sequence stratigraphy, initially the term sequence was developed, and gradually from that basic term sequence, this subject actually grew up and it stemmed, gradually flourished, and other terminologies, other aspects gradually were incorporated into this system. So, the first concept of sequence stratigraphy, not in the name sequence stratigraphy, but it was first thought of by Barrel in 1917, when he first emphasized the link between unconformities and base level change. Now, again, what is the base level change? So, that we will discuss later on. Basically, it is the equilibrium surface of erosion and deposition. So, it may get changed depending on the sea level conditions or many other factors. So, in 1917, almost more than 100 years back from now, first time the concept of base level change was linked with unconformities. It was done by Barrel in 1917, and that can be considered as the first concept developed in the realm of sequence stratigraphy, but at that time neither the term sequence was known to anyone or neither the term sequence stratigraphy was known to anyone. The first time the term sequence was proposed and defined by Schloss et al. In 1949, again long back, almost 75 years back, where they try to identify the stratigraphic units bounded by subaerial unconformities, and they defined that as a sequence. And based on this concept, Schloss in 1963 further subdivided the entire Phanerozoic succession of the interior craton of North America into 6 major sequences. So, that can be considered as the first structured sequence model that we got. Then we got this sequence stratigraphy in a proper way, where we get a more expanded definition of sequence, which was given by Mitchum in 1977, where he included the terminologies like relatively conformable succession of genetically related strata, which is a very important phrase commonly used in sequence stratigraphy or to define a sequence. So, relatively conformable succession of genetically related strata, those strata which are genetically related and they are conformable within that package, that can be considered as part of a sequence. So, this concept was first proposed in 1977 by Mitchum, and similarly we got further clarification from Petitjean in 1975, who redefined the meaning of the term sequence to include a vertical succession of phases that are organized to a coherent and predictable way. So, up to this end of 70s, 77, 75, up to that time, all these definitions, all these approaches were bit limited. They had certain limitations in terms of the defining that packages in terms of unconformity, because after that time it was found that not all the successions are actually unconformity bounded. So, then the question arises that if the succession is not unconformity bounded, in that case cannot we apply sequence stratigraphy? So, then it was further defined in 1994 that these unconformity bounded units are equivalent to Schloss sequence, but there are other sequences which are not following the Schloss sequence and they are following the definition given by Mitchum 1977, where the term correlative conformity was introduced. So, when this term correlative conformity comes into consideration, it does not restrict the succession to be covered by unconformity only. So, there may be continuous successions without any unconformity, and that can be considered as a sequence, or that can be considered for sequence stratigraphic study. So, with this I will stop over here. In last 30 years, several other aspects within the sequence stratigraphy has evolved, and those concepts has actually enriched the branch of sequence stratigraphy, the subject of sequence stratigraphy, and nowadays we can apply this concept of sequence stratigraphy in very high resolution, irrespective of whether there is an unconformity present or not. So, how we can do that? What are those aspects that we will try to reveal in this particular course in our next classes, and there we will go very systematically. So, basically in today's class, if I try to summarize very briefly, we have tried to understand the concept of sequence stratigraphy. What is sequence stratigraphy, how it is advantageous over other branches of stratigraphy, what we commonly do in sequence stratigraphy, what are the common inputs, common pillars of sequence stratigraphic study, and how this subject has evolved. In a very brief way, we have just gone through that part. So, these are some of the references that I would suggest you to follow, where you will get all these informations. So, thank you very much.